Hey guys, welcome to Tech Learnings. I'm back, and it's been quite long since we had our last session. Uh, I think few months, I would say, but yeah, got caught up in certain things, certain projects. Few important things came up in between, so couldn't meet you guys. But yeah, that was past. But now present is that we'll be learning more and more, and I'll be doing things which I really enjoy, and definitely knowledge sharing is one of them. So Java 10, basically, if you know that Java 10 version has been released by Oracle. So today's session is basically focused around Java 10. We will see that a few important things which has came up with the Java 10, and in fact a lot of things have come up, but will this session, the scope of this session will be limited to two important things, two important features, you can say. One we call as a time-based versioning, right? So versioning of Java has changed with Java 10, and another we call as local variable type inference. Okay, so these two features will be trying to understand today what has happened with Java 10. Okay, so let's get started without means wasting our time. So since Java 9, actually we have this class called version. Okay, java.lang.runtime.version, and if you see here, this is since Java 9. Okay, so I just import it, version v equals to runtime dot version. You can simply get its reference, and let's just try to print it, what it says, what is the current version in this project which I'm using. We can see here the JRE used is Java SE 10, so we want to know the exact version. Let me just run it. So it states that 10.0.1 and plus 10. Okay, so this is the version of Java in this application. Now what these numbers signify: 10, 0, 1. Okay, and before we move, let me show on terminal as well what is the Java version installed on this laptop of mine. So it is also saying 10.0.1, and it is showing a date, all right, the release date. And then we have SE runtime environment 18.3. so what is this 18.3 meaning? It is 18 is the year basically, which is 2018, and 3 is the third month of that year. Okay, so build is 10.0.1 and plus 10. What is plus 10? You can see here as well, it is plus 10. So 10 here signifies basically the build number. This is the 10th build of this version. This is the 11th build, 12th build, 13th build, right? So if it is 11th build, it will be plus 11. It will be 12th build, it will be plus 12. Okay, so this is the build number, and here we have Java hotspot, which is 64-bit. Okay, so this also we can see here the version. Now this version is basically made up of few parts, you can say. Let me just print before we see what exactly do they mean. So first is feature. Okay, so 10 here means the feature, the first thing. Then number 2 is we call as a interim. This number signifies interim, which is 0. Then third one signifies the update, and fourth one signifies patch. Okay, so let me just print it. So 10.0.1 and 0, since there is no patch for now. We can see in the source code of this version class as well. Let me just go to line 896, and here we can see this is feature.interim.update.patch. Now what does this mean? Feature counter will be incremented with every feature release regardless of the content, right? So with every feature release, like as the name also saying, with every new feature this counter will be incremented. And it's not that features will always be added, they can be removed as well, right? They may also be removed. Fine. And incompatible changes may be made whenever it is justified. So this first number signifies feature, second number signifies interim, right? So it will be incremented for non-feature releases, right? Because feature releases we already have one counter. So for non-feature releases we have interim, that contains what? Compatible bug fixes and enhancements, but no incompatible changes, right? So this is interim. And update. Update is basically that fix security issues, regressions, bugs, or in bugs in the new features that have been added. So this is in update. And what is a patch? Patch is basically some emergency fix that you have to just deploy. Means patch is something like some critical bug that may be found out in this version, so they may have to release it, right? So that is why this patch has been taken care of, emergency patch release counter, and it's incremented when it is necessary to produce an emergency release, right? So these four things. And there is fifth also, fifth and later elements, means there can be more as well, and they are free to use by the platform implementers, right, to identify the platform specific patch releases or implementer specific patch releases. So this is about version. For now we can just restrict to feature, interim, update, and patch. So feature is for features, interim is for non-feature releases, update is for your counter and incremented for compatible update releases, and patch is for your critical fixes, some emergency kind of fixes. So this is about version. Okay, so next thing, local variable type inference. So before, I think we have been used to, right, we have been writing int I equals to 10, right, float, let's say f equals to 10.4f, right? We have been writing all these variables, right? We have been doing type declarations. I think since I learned Java, I'm used to this, right? Whenever you have a type of variable, you have to declare what type of variable is that, the data type of that variable. But if you see the other languages, there you do not have to, means there the type declaration is not such means restrictive. You have to, in other languages, like for example in Python, right, you can simply uh, give a keyword and then name of your variable, and then you can store any type of value. So something similar, or you can say same, has come up in this version as well. There is a keyword called var. Okay, now what you can have var a equals to 10, which is an int, right? You can have var b equals to, let's say, a float. You can assign a float to this variable. Var c equals to, let's say, a double value can be assigned, right? Where d equals to abc, a string value can be assigned, right? So here, are you defining the type? No. So Java has now become more intelligent with Java 10. You do not have to necessarily, right? This is there for backward compatibility, right? But there is an option now that it can implicitly determine the data type for you. Fine. So this is local variable type inference. Few things which we can't do with this var keyword, you can say. We can do this, let's say int e comma f equals to 0, but can we do var, let's say g comma h equals to 0? No, we can't, right? Is there any error in this line? What is the error? Oh, f is already defined, no issues. Let me make it f1. Fine, we can do this. This we call as a compound declaration, right? So we cannot do compound declarations, cannot use var on a variable without initializer, right? So if I write this, is this okay? No, var is not allowed in a compound declaration. So compound declaration is not allowed with var. Fine. And let's say ij, because we usually use, let me use xy. So can we have something like this, variable var x? No, cannot use var without an initializer, right? Can we have int y? Right, so this is proper, this is valid, but this is not valid. So we cannot have uninitialized var variable. We cannot have compound declarations, right? We cannot have null value assigned to it as well. For example, let's say integer z equals null. Fine, we can have this, but can we have something like, let's say, where z1 equals null? No, right? It's a compile time error, and you can say this cannot infer type for local variable initialized to null. Fine, is it okay? So basically it cannot determine, Java cannot determine what is the type of this variable. So you cannot have null values assigned, you cannot have compound declarations, you cannot have uninitialized your type inference, right? Cannot use var on uninitialized variables basically. So this is how is it different from your normal data type variable declarations, and this is how you can use var. One more thing before we wrap up today's session. For example, we have been using write for, let me just create a list, let's say list of integers, let's say I said numbers. We can just have a list of, and let's say 1 2 3 4 5, any numbers, random. And what we are accustomed to, if I just want to run a loop, for each loop, I is already defined, apologies, I'm using variable names which are already there. So and we can just print, okay. Alright, this is the way we are accustomed to. We have to write int here because since this is a list of integers, so this code will of course run. Alright, it will print the value of this list, the numbers that are there. So instead now we can have var here as well. Fine. Similarly, we are accustomed to writing int I equals 0, I less than numbers dot size I plus plus, and I, and let me just comment this. Fine. So yeah, here also we can do the same thing. So this is local variable type inference. Now Java has become more smart, more intelligent, that it can determine the type of your local variables implicitly. And second feature we talked about is time-based versioning. I hope you are now aware that what is versioning and how the things are going to change. In fact, one last before we wrap up again, so Java is basically saying that we'll be releasing our versions every 6 months. Means in a year you will have 2 releases, and like for example current version is Java 10, so Java 11 is going to be there within this year itself, right? So now we will have frequent increments in the Java version. So that's it about the versioning part. Okay, so that's it for today's session, and I hope you guys understood at least these two things that are there with Java 10. Like I said, there are a lot of things, but these two we wanted to see in this session to keep the scope limited, otherwise it will be a bit lengthy. So thank you so much for watching, and see you guys again. Thank you.